So when you look at the problem, these are all set up the same way because they only have one set of like curves and lines intersecting that, and the cross sections are what is different. So these are all these problems. Once you set them up, the rest of the worksheet can be done in 10 minutes or less. Like, it's a real quick worksheet if you can set up the problem. So when they tell us perpendicular to the x-axis, what does that tell us about our integral? Yes. X's. It's x's for everything, right?
Oh, yes.
So that means this equation right here, do we want it in terms of y?
No, you want
No.
We want it in terms of x. So I have to solve for the y, and what do I get? Plus or minus square root of x, right?
Yep.
Okay. And then we have the line x equals 9, right? So what I would do is, well, this throws me off the way the picture was drawn because I like to think of my axes like that, right? Okay. So when we have this all in terms of x, do we do right minus left or top minus bottom? Top minus bottom. So one of the first things we have to do is we have to figure out what our slice is. So if we are looking at this picture and we do top curve minus bottom curve, then what do we get for a slice? Positive square root x minus negative square root x. And so what is each slice? 2 square root x. Okay. And then if we look at this, we have x values, right? What are the x values that we're evaluating for? 0 to 9. Okay.
So why are we minus the square root?
Because when we do, whenever we do this to find our region, we do top curve minus bottom curve. And this is a parabola that's graphed on the x-axis, and the top curve is the square root of x, and the bottom curve is negative square root x.
So if you would split that square to half and have you do 2 rectangles, divide it like that, that's this equation.
No.
We did.
If you did square root x to 0, and then did a rectangle instead, and then just doubled it, you'd get the same answer. Yes.
The problem is on the back side.
Yeah. So the general formula for all of these problems is evaluating it from 0 to 9 of whatever the area of your cross section is, and then just plug it in. You're done, right? So for the rest of this, we just have to know what the formulas are for the different cross sections. So what should you have done for number 1? Yeah. So 0 to 9 of the slice squared. Okay. What should you do for number 2?
0 to 9.
0 to 9. And if we look at the board, I wrote it down. We said base times height, but we said the base is always the same as a slice, right? The base of the rectangle is a slice. So if we have base times height is actually slice times height, and they say that you have a height of 2.
Slice of 2?
Yeah, slice times 2. So I'm going to say 2 times 2 square root x, right? Okay. And then how about semicircle? Yeah, so 1/8 pi slice squared. Okay. Did anyone figure out the quarter circle?
Yeah.
Now, I was going there too. You have to think about what the slice is. So over here, the slice was the diameter, correct? Right? Do you see that? That your slice, your cross-section slice, the circle, when you set it up on top of that region, the root x minus negative root x, the length of that slice happens to be the diameter of the circle. Do we all agree with that? Okay. Flip the page. Is the cross-section slice the diameter of the circle still? No. Do you see that? What is the slice representing this time? The radius. Okay. So our formula, we can't just take the semicircle formula and divide it in half for a quarter circle, because that semicircle formula that we have is based on the diameter. It is not based on the radius. Does that make sense? It is based on the slice being a diameter, not a radius. Here, we have that S is the radius of the circle, right? So pi r squared is a full circle, right? So what would a quarter circle be? 1/4 pi r squared. And then r equals the S. So for this particular problem, S and the radius happen to be the same thing. I agree with you, that's kind of tricky. When I stared at the other teachers' examples, it took me a while to figure out that's what they did. So we've got from 0 to 9 of 1/4 pi S squared. Okay. What should we have for equilateral triangle? Yeah, root 3/4 times S squared. How about for a triangle with the height equal to 1/4 the length of the base? So we know that the formula that we used is 1/2 base times height, and we said that the base is the S. And so if the base is the S and the height is 1/4 of the base, then we would say 1/4 S. And so I think Erica said 1/8 S squared. That was perfect.
Oh, yeah.
Okay. And then the last one. Now this one you really had to think about because I did not give you this formula at all. So can you guys remember the trapezoid formula?
So then it would be 1 times 1/4 height base on
Right? Okay. So if we look at this, it says the upper base is equal to 1/2 the length of the lower base. So what letter does the lower base get to be called? S. So I went ahead and called that base 2. And so the upper base would be what? 1/2 S. And the height is 1/4 the length of the lower base. So it would be 1/8. Wait. Oh, you already multiplied them. 1/4 S. Okay. So in the front, I had to do some simplifying here. That's 1/8 S in the front multiplied by 3/2 S in the parentheses. And so what do we get? 3/16 S squared. There we go. Okay. So I want you to plug these in, and I am not your calculator. And do not take turns. Every single one of you individually is plugging these in for yourself because we're going to get better at this. We're going to get quick at this. We want to make sure we can type everything in correctly, get parentheses in the right spot.